2,000 years ago, temples faced a surprisingly modern problem. Worshippers could easily take more holy water than they had paid for, so an ancient engineer built one of the world's first vending machines. Within the grand temples of the ancient Mediterranean, administrators needed a way to distribute this sacred liquid fairly. There was no simple method to control the amount each person received. To understand this vulnerability, we must observe how a temple functioned. Holy water was an important part of purification rituals. This liquid did not appear spontaneously. Sourcing it required a massive logistical operation. Workers traveled to specific sacred rivers or deep wells. They hauled heavy clay amphorae across miles of uneven terrain under the scorching sun. The priests executed complex purification rituals. Finally, laborers poured the liquid into heavy bronze ceremonial basins placed at the temple entrances. Every drop represented physical labor and financial cost. Temples implemented a straightforward exchange protocol. A worshipper deposited a coin into a collection box and extracted a designated amount of holy water. The system relied entirely on trust. Trust was difficult to enforce. Because the water sat in an open basin, it was difficult to control how much each person took. Worshippers approached the basin with a psychological disconnect. They stood in a sacred space, surrounded by stone and incense. The open basin created a simple weakness. There was no physical barrier preventing someone from taking more than intended. A worshipper deposited a low-value bronze coin, fulfilling the initial obligation. When reaching into the open basin, the behavior changed. They did not extract a few symbolic drops. They could simply take more than the system was designed to allow. They extracted a volume drastically exceeding their payment. The unverified extraction created a critical logistical failure. The temple had no reliable way to control the amount distributed. Human security introduces an operational liability. It depends on constant supervision. Guards suffer from operational fatigue. They require sleep. A temple operates continuously, dealing with massive crowds, noise, and chaos. Monitoring every single basin at all hours of the day was impossible. In those unmonitored moments, during shift changes or a single distracted glance, unauthorized extraction multiplied. If human security was too vulnerable to fatigue and distraction to protect the temple's assets, how could a system enforce absolute compliance without human presence? The answer emerged in 1st century Alexandria. In the 1st century AD, Heron of Alexandria proposed a mechanical solution. Operating as an engineer in one of the greatest technological centers of the ancient world, he did not analyze theology. He analyzed mechanical efficiency. Heron's design removed the need to trust the user. Words couldn't enforce the rule. Metal could. In effect, he established an absolute physical checkpoint. He created a mechanical system that enforced the transaction automatically. The design was completely enclosed. He constructed a heavy sealed bronze vessel. Worshippers could no longer access an open basin. They could not dip their hands inside. They could not tip the heavy container. The liquid was locked securely inside a physical fortress. Interaction required a specific physical input. A person dropped a coin into a narrow slot at the top. The solution relied entirely on eliminating human discretion. How do you force a bronze coin to measure an exact volume of liquid without a single electrical component? The coin fell into the darkness of the machine. It landed onto a metal pan attached to a lever, acting like a small mechanical seesaw. The system relied on strict gravity. The weight of the coin pushed one side of the seesaw down. This motion lifted the other side. The rising lever pulled a vertical rod. This rod opened a valve at the bottom of the tank. Water flowed out. The worshipper received their commodity. The machine could stop itself automatically. Heron engineered a geometric failsafe. The pan holding the coin was not flat. It was slightly tilted. As the water flowed out of the bottom, the coin slowly slid down the slanted surface of the pan. The angle of the tilt controlled how long the valve remained open. Once the coin reached the edge and fell off, the weight disappeared. The lever instantly lost its counterweight. It returned to its original position. The vertical rod dropped. The heavy valve slammed shut. The flow of water ceased immediately. The transaction concluded. The machine reset itself in perfect silence, ready for the next user. The purpose of the machine was not just to demonstrate engineering, it was to solve a practical problem. And that is exactly why this apparatus mattered. The machine neutralized human error. It did not need sleep. It did not blink. It did not get distracted by the crowds. It could not be intimidated or bribed. It forced the worshipper to comply with the rules through absolute physical boundaries. The temple no longer had to rely on human honesty. The machine helped ensure that worshippers received only the amount of water they had paid for. The mathematical equation of input versus output finally stabilized. The temple secured its supply line. It changed the behavior of the masses by removing the opportunity for uncontrolled extraction. 2 millennia before the advent of electricity or digital retail. The fundamental architecture of the vending machine was fully operational. It stood inside a stone temple, proving that while technology changes, human nature rarely does.